remote sensing, electromagnetic spectrum, electromagnetic bands in remote spectral signature of soil, rock, water, and vegetation, thermal, infrared, and microwave remote sensing, digital image processing, Landsat, IRS, and spot characteristics and use, aerial photos, type, scale, parallax, relief displacement, element of image interpretation. So basically, this is your syllabus, which will be completed. Okay, so before going to remote sensing in detail, so first of all, tell me what do you mean by remote sensing? Anyone? So yes, that's correct. With information about an object of interest without coming into physical contact. Okay. So in case of this remote sensing, we use this remote sensing in daily life. Okay, in our daily life, we use remote sensing. For example, we see things. Okay, for seeing the things, we do not have to physical contact. Like I am seeing the laptop screen. Am I in physical contact with the laptop screen? So this is the best example of remote sensing. The seeing. Okay, you are your sight, your eyesight is the best example of remote sensing. Apart from that, give examples in your daily life by which you are using remote sensing. Think think and give examples. Microwave cooker, that is a remote sensing. Okay, microwave cooker. Microwave oven, you said it. Microwave oven is a remote sensing. Okay, and listening is also a application. You are listening by coming into physical contact, or from a distant sound you are listening by your ear. Listening is a remote sensing thing. Smelling is a remote sensing thing. Okay, so these are the remote sensing things we use in our every second of life. Listening, this seeing, and this smelling. So also feeling the heat of sun. Okay, feeling the cold. These are also remote sensing. Okay, so we have to remotely sense the thing. Okay, we have to distance the things or is called exit. Sorry. So in this remote sensing, also geoexploration things we do, like the airborne gravity survey, airborne magnetic survey, geomagnetic survey. Okay, these are also remote sensing things. Okay, so remote sensing is the process of inferring surface parameter from measurement of the electromagnetic radiation surface. So basically, this concept what, that we have to gather information without coming into physical contact. Okay, so this process is called remote sensing. We have applied this process using several instruments, and then we gather informations. Okay, so for gathering this information, we have to first use an energy. Okay, we have to first energy which will be incidented on the object, and that will be reflected back, and so when we are seeing an object by using our eye, so what happens? First, the sun's ray is incidented on that object, and after that, the energy is reflected back to our eye, and after that, the cornea of our eye makes that image. Okay, makes an inverted image, and our brain then again inverts and makes it straight image. Okay. So like that, certain energy may be energy, artificial energy. That energy is incidented object. Then this object reflects, absorbs, transmits, scatters. These four processes occurs. Okay, we'll read about that four process. But these four processes will occur, and certain energy to our detector is our eye. Okay. So energy is coming from the sun. This is our object, and this is our eye. Okay, so this will be reflected back, and here the inverted image will be created, and after that our brain will again re-invert it to. Okay. So like that, this energy is called as electromagnetic spectrum or electromagnetic radiation, which comes from the sun as natural source. Also we use artificial source. So based on that, active and passive remote sensing came. I will study it later in the later slides. So for that we are studying the electromagnetic spectrum. Okay, so in electro is used for your remote sensing. So electromagnetic spectrum, why this is called electromagnetic spectrum? Anyone? It is written here and also shown in the figure. Why called as electromagnetic spectrum? Not wave, it is a single wave, but this wave has both electric component and magnetic component. Okay, so this electromagnetic energy, this includes both electric component and magnetic component. So both vibrates perpendicular to the propagation direction and also perpendicular to each. Okay, so see here, you can see. So this is the propagation direction. This is the component, and this is the magnetic component. Okay, so this is the propagation direction. Both vibrate perpendicular to the propagation direction and also perpendicular to each other. Okay, so that's why these are called as electromagnetic spectrum or electromagnetic. Okay. So they propagate sinusoidal pattern or wavy pattern. So they are basically related by three parameters, that is frequency, and their velocity, and their wavelength. So electromagnetic spectrum velocity is always called as c, that is 3 into 10 to the power 8 meter per second. Okay, that is the velocity of or speed of light. Okay, you can also take it as 2.99 into 10 to the power 8 meter per second. Okay, so by rounding it, it is 3 into see, you know, this is the wavelength, crest to crest is the wavelength. This is how much wave passed through a particular point in a particular time. That is frequency measured in hertz. So C is lambda f is basic spectrum. Okay. So this electric spectrum is divided into various your parts. Okay, various parts, various, you can say various energies. Okay, so they are divided based on their wavelength, or you can say frequency. You can divide based on their frequency or based on their wavelength. Both you can use. Okay, so based on their wavelength, their use is also different. Their use is also different. We use like, if you will go and if you can see here gamma ray, X-ray, UV, visible, infrared, microwave, radio. Okay, gamma ray, X-ray, UV, visible, infrared, microwave, radio wave. So these are the major divisions of electromagnetic spectrum. So there is no certain line of division. Okay, remember that there is no certain line of division in these wavelengths. There is no specific line of division. So there is a range of things. There is a range of wavelength where they are divided into these rays. Okay, so you know, in these waves, certain waves, you know these things. Okay, give me examples of use of gamma rays. Why gamma ray is used? Gamma rays are used for what? Everyone give one example. Gamma ray use, X-ray use, UV ray use, infrared use, microwave use, radio wave use. Gamma ray is used for logging. Good. Yes, gamma ray is medical, for medical treatment. Okay, for medical treatment, gamma ray is used. Okay, gamma ray logging is also done. Gamma logging and medical treatment is gamma ray also used. Then X-ray. Yes, X-ray is also used for medical purpose, that is identifying bone and bone fractures. Okay. Apart from that, why X-ray is used? What type of scanning? Yes, scanning. Yes, yes, security scanning. Yeah, it is used for security scanning. Good, very good. Then yes, that is very good. As a geologist, you have to first say that XRD. Okay, first XRD. This is expected from a geologist, that use of X-ray is for XRD. Okay, X-ray diffraction method. So can you say there are two types of, okay, there are two types of X-rays. One is hard X-ray, one is soft X-ray. Remember that the lower the wavelength, the most dangerous is the wave. Okay, gamma ray is the most dangerous, then X-ray, then UV ray. Okay, these are dangerous, means they can cause us health problems. Okay, they can cause us health problem, because why? Because why they can cause health problems? Anyone? What is the common thing that they can cause health problems? In not invade? No, no, no. Yes, 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 very good. See, very good. So they have ionizing tendency. So when they pass through the path, na, they ionize the path. Okay, they what they do? They just break the air, or break the particles which they pass through. So they ionize. So when they are when we come into contact with some ions, na, ions have energy. So the energy affects us. So the common thing is they ionize the things. Okay. So gamma ray, X-ray and UV ray, these are dangerous for human health or any kind of animal health. Okay. So XRD. So gamma rays, X-ray, yes, XRD. So in X-ray, there are two type of X-ray. One is hard X-ray, one is soft X-ray. Okay. So hard X-ray is this short wavelength site. Okay, in short wavelength side, the hard X-ray is there, and the higher wavelength, that is soft X-ray. Okay, there are certain margins also, like the ranges. So the hard X-ray is used for medical purpose. That is for identifying your bone fractures and these all things. And the soft X-ray is used for this your security scanning. Okay, for security scanning, the soft X-ray is used, and also hard X-ray is used for XRD. Okay, this is just a general knowledge. That's why I have told you. Okay, next is use of UV ray. Anyone? Use of UV ray. Treating skin cancer for UV rays, or UV rays cause skin cancer. So is it a use of this UV ray causing skin cancer? UV ray, use of UV ray. Anyone? Use of UV ray. Use of UV rays causing skin cancer is dangerous for us. Sanitization of goods, very good. Sanitization of not goods, sanitization of medical equipments. Okay, sanitization of medical equipments. And UV rays, UV rays is used as insecticide and pesticide in restaurants. You don't, there is a UV ray box na, where there is no blue light. What blue light? That is UV box. Okay, that is soft UV, means very low wavelength UV to kill, not to kill flies. Basically, these UV rays keep them away. Okay, but to certain things, they come into contact with these UV rays and they got killed themselves. Okay. Apart from that, in electrolysis of water, okay, electrolysis of water, UV rays is also used. Okay, used in detective activity. What type of activity they use in for UV ray? Fingerprint detection, is it done by UV ray? I don't know actually. I am asking. Fingerprint detection, they use UV ray. Yes, blood stain detection, it is right. Yeah, blood stain detection, they use UV ray. Yeah, yeah. Fingerprint detection, I don't know actually. Okay, so these are the uses of UV ray. Okay, and after that, this is the visible light. Visible light is the light which is sensed, which can be sensed by our eye. Okay, these are divided into seven colors and three primary colors. Three primary colors are RGB, red, green, blue, and seven colors of this visible light, that is VIBGYOR, violet, blue, green, yellow, orange, red. This is from 400 nanometer to 700 nanometer. Okay, this you remember always. Okay, or 410 to 730 also some say, 410 to 440 to 660 also say. So 400 to 700 nanometer. Okay, this is the wavelength of visible spectrum, and where red is the wave which has higher wavelength. So can you say why red light is used in traffic signals for stopping? Why do not they use green line for stopping? Why green line is for moving? Yes. So red light can be viewed or can be seen from a long distance. Why? Because it has long wavelength. Okay, it has long wavelength. Okay, longer wavelength than other lights. So it can be seen from distance. Okay. Okay. So this is the visible light. Then we are going to infrared. So in infrared, there are two types of infrared. Into three types: near infrared, middle infrared, and your thermal infrared. Someone class it as long infrared and or your near infrared and shortwave infrared, SWIR. Okay. So these are the classifications. Wait. Okay, these are the infrared. So why infrared is used again? Why infrared is used? Give examples. Infrared photography. Okay. Yes. Not during Corona. Yes. Remote sensing. Good. Why you have not given examples? Okay, I have not asked. Okay. Night vision. Good. Why night vision? Suraj, why infrared is used in night vision? Vegetation detection. All these uses are related to one single property of this infrared. Yes, that is the thing. The infrared is sensible to temperature. Infrared is related to temperature. So infrared can detect temperature. The high temperature areas will be seen as a bright spot, and the low temperature areas will be seen as a dark spot. Okay, that's why infrared is used for these all things: temperature detection. And this night vision is nothing else but the detection of temperature only. Okay, vegetation detection. Okay, these are all related to temperature detection. Apart from this temperature detection, what is the uses of infrared? Apart from the temperature detection, what are the Uses in your daily life. Uses of infrared in your daily life. Yes, that's a good example. That is remote. Okay, that is remote. Every remote works on the principle of this infrared. Okay, every remote. You can say it as TV remote, you can say it as AC remote, you can say it's fan remote, any kind of remote, and you can say it as the remote of this your car. Okay, remote key of your car, everything works on this infrared. Okay. So these are the things. Then again, yes, let's move to this microwave. So same use of microwaves. What is the use of microwave? Yes, microwave oven. Can you tell what is the concept behind microwave oven? What is the concept? Does microwave oven heats the food? Does microwave oven heats the food? Heat the food? माइक्रोवेव ओवन फूड को गर्म करता है कि नहीं करता है? मनमत, व्हाई नो? Dielectric heating. No, no, no. They don't give heat to the food. Okay. So, yes, that is indirect heat transfer. But the thing is, uh, all of you have used the microwave oven. So, the plate you have placed in microwave, that do not gets heated, but the food gets heated. Yes, yes, yes. That is the thing, Gaurav. Very good. So basically, microwaves they vibrate the water particles. Okay, they ionize and vibrate the water particles. That's why the heat produces. If there is no water in the object, or if there is no water in the food, that will not be get heated. Okay, so that's why the plate you use in microwave that's get heated, that's get not heated, but the food gets heated. You're getting it? Just you just place the tea or you just place the coffee inside the microwave oven, you will see that the cup is not heat at all, but the coffee is heated because of that water molecule. So basically microwave does not heat the food, it heats the water molecules inside the food. Okay, so that is the concept behind the microwave oven. Okay. So microwave are used in cooking foods. Then radio waves. Radio waves. Give example of radio waves. Usage of radio waves. That is remote sensing. So basically radio waves are all kinds of communication thing. Okay, all way of communication, TV, radio, satellite communication, mobile communication through this through these towers, and then your mobile communication and your aeroplane communication. Okay, all these communication things are done by radio waves. So these radio waves are divided into several spectrums. Okay, several spectrums, this type of things. Okay, this type of things. Then this spectrum is sold by the government, that you can use this spectrum like X to Y wavelength. You can use this spectrum. That is the thing. 2G spectrum, 3G spectrum, 4G spectrum, 5G spectrum. So what is the difference between this 2G, 3G, 4G, 5G? Anyone? Why this generation? Why this fourth generation speed? Why this fifth generation speed? Anyone? Why the speed is increasing? Frequency body ଯାଉଛି, yeah, yeah, that thing. Increase in height to which they can touch and reflect back. No, 3G, 4G, these are not related to height, Niteshri. Due to wavelength bands. Yes, yes, they are divided due to wavelength bands. But why the speed is increasing? Why the speed is, if they are divided, if they are simply divided into wavelength bands, they can do the like the 7G can be developed in 2000. It's why technology is not here. See, if you low frequency will long distance, loss will travel long distance. Take, okay, this can, if you are using low frequency, if you are using low frequency, then if low frequency uh, long distance time can prolong, and it will, the energy will lost, the energy will not be lost significantly during traveling. So if you are using low frequency, it can travel more distance, but if it will travel more distance, it will take more time. Now we are going to high frequency, then it will travel, okay, it is high frequency. So the energy lost will be significant in shorter distance. In shorter distance, more energy will be lost, but this will travel in a less time. This will take less time, but this will not travel to a far distance. This will travel to a short distance. In a shorter distance, as it is high frequency, repeativity is very high, the energy will be lost drastically. So it can travel a shorter distance before it gets destroyed. You are getting these two concepts. If you are using low frequency, the energy lost will not be significant. It can travel more distance before getting destroyed. If you are using high frequency, the energy lost will be significant because its repeativity is very high than this low frequency, but it will take less time to travel for a certain distance, but it will be destroyed rapidly than that of low frequency. So that is the technology behind this 3G, 4G, 5G, 6G, whatever that G. Okay. So if you are using low frequency, then you have to place these mobile towers in a distance thing. It will be okay, no worries. Because here this is the tower, here this is the tower, consider this a 10 kilometer, but you can reach. Okay, you can reach, a mobile phone can be reached to this tower. Okay, but when you are using high frequency, you have to use these mobile towers in a shorter distance, very shorter distance, like 100 meter or 200 meter. This will be the general working area or working perimeter of one tower. But in case of low frequency, the working perimeter will be 2 kilometer, 3 kilometer, 5 kilometer. So if you are developing technology for 5G bands, then you have to place towers in a shorter distance. The the radiation will be destroyed in a very okay. So that is the concept behind 4G, 5G and 3G, 4G, 5G. But the technology is like you have to develop device. You have a device which can capture this wavelength, this band, this frequency hertz. Basically, these are divided on the basis of frequency. Yeah? Wavelength is the background thing, but the generalized use is frequency. So frequency also 5G bands are called as millimeter bands. Okay, millimeter bands. They generally use the frequency. The higher the frequency, the speed will be higher. The data transfer speed will be higher, but the data transfer distance will be shorter. Okay. The lower the frequency, the data transfer speed will be lower, but the distance will be higher. You can observe that during the 2G spectrum, okay, during the 2G spectrum, almost all the area you are getting good network. But in case of 4G, in case of 5G, what is going on? There are very high amount of network issue. Now this technology developed, that is VoLTE. Okay, VoLTE, voice over LTE. Okay, voice over long term evolution. So 4G is called as long-term evolution. So VoLTE, what they do now, they are not transferring this voice over this network. So now they are transferring this voice over this optical fiber. That is voice over LTE. That is you are calling it as Wi-Fi calling. Wi-Fi calling is not but similar to voice over LTE. VoLTE, you are using the mobile network. Wi-Fi calling, you are using the Wi-Fi. Nothing difference is there. Okay, so this is the 4G, 3G. The bands government sells the bands, particular ranges of wavelengths or particular ranges of frequency. Government sells to the public that you can use this band. Okay, not recently, before 2 years or 3 years, you must have listened that in USA this 5G is banned because of this 5G bandwidth was matching with the airport traffic controllers wavelength. Okay, so they are thus their certain wavelength is reserved for ATC, airport traffic air traffic controller. Certain wavelength is also reserved for military use. Okay, so these 5G bands should not interfere with this. If they will interfere with this, then their communication will be distorted. Okay, so that are the things. So these are the radio waves, they are used for communication. Everyone understood? Okay, so these are all the bands, they are used for remote sensing. Okay, they are, oh, sorry, they are not used, all are not used for remote sensing. For remote sensing, this thing is used. And a short thing of UP ray 0.3 to something, I will see that in the next slide. Okay. So these gamma ray and X-ray are not, and UV rays are not used for remote sensing because they are harmful for animal health, human health. Okay. So these are used for remote sensing: visible light, infrared, microwave, radio wave. Everyone got it? So these are the divisions, basic division you can see here. Basic range. These are not fixed actually. Okay, these are not fixed. These are very like you can say transitional in nature. Okay. Somewhere I have mentioned the uses, but I think that slide is not here. So let's see the role of remote sensing. I already have told you that certain energy is emitted from a from an object, or that may be a natural object, that may be an artificial object, and after that the incident energy is reflected back and sensed by a sensor, or that is called as that is also called as the scanner. Okay, in case of remote sensing satellites, and they are mounted in a platform. These scanners are mounted in a platform. Okay, that may be aircraft, that may be a satellites. Satellites carry nothing but a big camera, very big camera. Okay, the aperture is very big. Satellites, these remote sensings are nothing but photos only, simple photos. Okay, not simple photos, digital photos with many informations that can be extracted by you. Okay, so these things are called as sensors. The camera that capture photo, the camera is actually the platform. Okay, the camera is actually the platform. The sensor that captures the photos. Okay, that 10 megapixel, 15 megapixel, 1011 क्या वो 150 मेगापिक्सल. ओके 150 मेगापिक्सल का कैमरा देंगे हम लोग. ठीक है. बट can you tell me why this Apple mobiles 12 megapixel camera is very good, but this Oppo, Vivo and this Chinese mobiles 150 megapixel camera is not good? Anyone? Why? Why this difference? It is higher in megapixel, but why this thing is there? Pixel is yes, pixel is much more, so photo should be good, na? Photo should be good, but this Apple 12 megapixel gives very good photo. Sensor issue. What is the sensor issue? Good sensors in Apple than in Chinese. Like, see, there is no good sensor, there is no bad sensor. Okay, there is no good sensor, bad sensor, because sensor has only property. This is a sensor. This has only property to gather information. Okay, gather information. After that, there is a image processing software which uh, processes the information or processes the back reflected radiations and gives you a image. Okay, you are saying that Steve is saying that image processing uh, iPhones. No, that is not the thing actually. That is not the thing. Image processing can be developed. Image processing software can be developed. A good image processing software can be developed. That is not the problem. The major problem I am telling you. See, this is your frame. Okay, think this is your frame. So my sensor size, not wider aperture, I am telling you. So my sensor size is this. Okay, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 pixels. Okay, 12 pixels. The same frame I am taking. Consider this is the same frame. Okay, consider I am dividing it like this. Now these are of 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 into 12. 160, 192. These are of 192 pixels. The same pixel, same frame. Okay, these are same. Consider this is my laptop and this is also my laptop with a different screen. This is 192 pixel, this is 12 pixel. You are getting the, are you getting the reference? So basically the camera pixel size is larger in Apple, but in this Chinese Oppo, Vivo, MI, these things, their pixel size is smaller. The pixel size is small, very small. So the larger the pixel size, the more information you capture. The more information you capture, the more minute details you capture. The smaller the pixel size, your photo will be pixelated. Your photo will be pixelated very easily. Your photo cannot capture, your sensors cannot capture good amount of information or healthy amount of information. That's why 12 megapixel of iPhone is very good than this 150 megapixel of Oppo, Vivo, MI, whatever. So the sensor size is large. Okay. So this 12 pixel also equal to this 192 pixel. But the 12 pixel will give you more accurate photo because the sensor size is good, sensor size is large, and it can capture good amount of energy. It can capture good amount of small amount of energy. If small amount of energy is captured, then the photo will be more distorted. If large amount of energy will be captured, then the photo will be more good. Everyone understood the thing? Okay. So that is the thing sensor. Okay. So let's move. So in a remote sensing process, what is the whole process of remote sensing? Okay, what is the whole process of remote sensing? Here it is written: emission of electromagnetic radiation. It may be sun or a artificial source. Okay, like it may be mounted on the platform. Okay, that on that basis passive and active remote sensing is done. First emission of electromagnetic radiation, then it will interact with the atmosphere. Okay, interact with the atmosphere, then it will be interact with the object, that is transmission, absorption, reflection, okay, and your scattering. These four processes are done. After that, this reflected back energy is absorbed by a sensor. Okay, transmission of energy from the object to the sensor, then recording of the energy by the sensor, then this sensor records this energy and transmits to the ground station, and this ground station, what they do, they process this image. Okay, they process this image and they send to computers, operators or scientists. They analyze the information. This is the whole process of remote sensing. Okay, active and passive remote sensing. So basically active and passive remote sensing, when passive remote sensing is done, there is a natural source, that is you are not generating the energy, that is passive remote sensing. Like you are using the electromagnetic energy of sun, that is passive remote sensing. And active remote sensing is when you are using your own source of energy. Okay, that is active remote sensing. So you can take example of a camera with flash, without flash. So a camera without flash will be active or passive? Anyone? A camera without flash will be active or passive? Very good. So it will be passive remote sensing because it uses the electromagnetic rays of the sun. Okay. So a camera with flash, it will be active remote sensing because you are using your own source of energy. So remote sensing platforms, basically the camera which is mounted in the platforms. Okay, the sensors are mounted in the platforms. Or it can be mounted in a balloon, in a helicopter, in an aeroplane, in a airplane with high altitude, and in satellite. Divided into ground level remote sensing, aerial remote sensing, and spaceborne remote sensing. Ground level remote sensing, these things are ground level remote sensing. Aerial remote sensing are these things, aerial remote sensing, and your spaceborne remote sensing are satellites. Okay, space shuttles, polar orbiting satellites, geostationary satellites. These are spaceborne remote sensing. So there are three types of remote sensing on the basis of acquiring information from certain height. So ground level, aerial remote sensing, and spaceborne remote sensing. Okay. So this is an example of ideal remote sensing system. What an ideal remote sensing system should contain? Okay, uniform energy source, like it will provide constant high level of output, high level of energy. Like you can take example of sun. Constant energy is provided by the sun. Okay, then non-interfering atmosphere, this is not possible there, that's why it is called as ideal remote sensing system. So non-interfering atmosphere means there should be no role of atmosphere in the whole process. Okay, then a series of unique energy or matter interaction means this energy and matter means this object, you can say this vegetations, buildings, these soils, these are our target matters. So the interaction between this energy in these matters should be uniform. Okay, then a super sensor which can acquire all the informations, real-time data handling system, and multiple data users. Okay, these are the parts of a ideal remote sensing sensor system, which is not possible. Okay, that's why remote sensing is there are some ideal remote sensing system is not possible. So what are the advantages of remote sensing? So provide data of large area in a smaller time, provide data of very remote and inaccessible regions. Okay, able to obtain imagery of any area over a continuous period of time through which, so okay, so you can get temporal data. Temporal data means multiple time, today, tomorrow, day after tomorrow, you can get the data of same place. Okay, relative inexpensive when compared to employing a team of surveyors. Four, 5 peoples will go and they will survey, but you have to just click a photo in remote sensing. Easy and rapid collection of data and rapid production of maps for interpretation. These are advantages of remote sensing. What are the disadvantages? Okay, so interpretation requires certain skill level. Everyone cannot study the remotely sensed data. Okay, needs cross verification. जितना भी रिमोट सेंसिंग डेवलप कर ले, ओके, जितना भी रिमोट सेंसिंग डेवलप कर ले, लेकिन फील्ड तो जाना ही पड़ेगा. Without going to field, you cannot get much information. You can get the information of the surface only. What about the ground, underground thing? You have to go field. You have to go field in any kind of thing. Okay, so data from multiple sources may create confusion. Skip it. Objects can be misclassified. This is processing error issue, and distortion may occur. Okay, these are the disadvantages, minor disadvantages. These are the major disadvantages. Okay, it requires certain skill level and needs cross verification with the ground field data. Okay, so these are the advantages and disadvantages of remote sensing. Yes, here I have given the slide. What are the uses of these things? So you just go through. I have already told you. Okay, this UV rays, this 0.204 micrometer wavelength is used for remote sensing. Okay, photographic UV band. This is called as photographic UV band. Otherwise, UV is not used for remote sensing. These 4 waves are used for remote sensing. So this microwave is the father of every remote sensing because it can penetrate rain, fog, cloud. Okay, like atmosphere is transparent for microwave. Why? Anyone? Why atmosphere behaves transparent to microwave? Yes. So the wavelength is small. Okay, basically the shorter wavelengths are transferred or transparent for the atmosphere, but the longer wavelengths are absorbed by the atmosphere, that is radio waves. Okay, so these are absorbed by the atmosphere, and visible rays are scattered. Visible rays are scattered by the atmosphere, but the microwaves are easily transferred through the atmosphere. But the microwave remote sensing is not very easy. Microwave remote sensing is very difficult. Sorry, yeah. So microwave remote sensing is not difficult. Microwave remote sensing is very difficult to process or analyze. Okay, because microwave remote sensing is not eye. Microwave remote sensing is ear. Okay, it is compared to ear. That is how much distance, from how much distance you have vibration you have listened, from how much distance. That is, microwave remote sensing is exemplified by ear. Other remote sensing are exemplified by eye, but microwave remote sensing is exemplified by ear. So in microwave remote sensing, the data are not like simple. Okay, you have to analyze it. But microwave remote sensing gives best, or best, you can say best results. Okay, best results, movements, you can say the earth movements, plate tectonics. Okay, these all things can be studied by microwave. All the other waves cannot do that. Okay, so microwave remote sensing requires very high level of skill to study. Okay, so next we are going to energy interaction in the atmosphere. So incident energy, when energy comes, it incidented on the surface or on the object. There are four processes which are done: reflection, absorption, transmission, and in the atmosphere it is scattered. Okay, scattered. So these are the things. So here it is given incident. This is the atmosphere. This is absorption, scattering. Here reflection, and this is transmission. Okay, and this is reflection back and scattered by remote sensing. No, subsurface features cannot be identified. It can be it can be the P can be given. Okay, the probability can be this kind of groundwater can be identified. Groundwater, because there is a moisture level which can be detected by infrared. So moisture level, the high moisture will high ground subsurface that can be identified based on micro data. Or if there are faults, certain kind of movements. Okay, if there's identify through microwave. Okay, we have to do, there is a symmetry. Okay, so symmetry by which identify the fault. Okay, in the we have either we have identified the fault, what type of fault is that,